Hello boys and girls, and welcome again to another science video lesson. In this video lesson, we will going to talk about the forms of electromagnetic waves. So these are the constituents of your electromagnetic spectrum. So in this video lesson, we will going to talk about the properties of these forms and also their effects to the living tissue. Alright, so come join me in this video lesson as we discover the different forms of electromagnetic waves. Alright, so we are now here in our video lesson. This is all about, still we are all about the physical nature of light, but we will going to talk about this session is about the forms of electromagnetic waves. So these are the constituents of your electromagnetic spectrum. So in the previous video, we have discovered the different properties of electromagnetic waves. Right? And also, we have encountered some parts of the electromagnetic spectrum, and we define the electromagnetic spectrum as the range of electromagnetic radiation that differs in terms of wavelength and their frequency. All right, so for today, in this video lesson, we will have the different forms of electromagnetic waves and also their certain effects. All right, the certain effects of these electromagnetic waves to our body. All right, so we will focus on that particular concept about the effects of the electromagnetic waves in living tissue. Alright, so to start with, let's start discussing first what are the properties of electromagnetic waves. So, just a general recall. Alright, just a general recall of the things that we have discussed in the previous video lesson. So, what are the properties of electromagnetic waves? Alright, so what is the connection between light, microwaves, and X-rays? All right, light, microwaves, and X-ray. Okay, so if we are talking about visible light here, visible light, microwaves, and X-ray are part of electromagnetic spectrum. All right, so definitely these three electromagnetic waves that you have right here are part of electromagnetic spectrum, and they are different, okay, in terms of wavelength, in terms of frequency. But they have one thing in common. They all have the same constant speed of 3 times 10 to the 8 meters per second. Alright, so these waves, alright, so these light waves are part of your electromagnetic radiation. Alright, so as we all know, the word radiation means energy transfer. Right? So the word radiation means energy transfer from one point to another, non-contact. Alright, so non-contact. So this is the energy transfer through waves. Right? So this is the energy transfer through waves, and the energy can be transferred from one source then to the receiver. Okay, something like that. Okay, so electromagnetic radiation. So that is how you classify. All right, that's how you classify this. Examples that we have right there a while ago. So we have light, microwaves, and then the X-ray. Also, we agreed that the electromagnetic waves are transverse waves. All right, they are transverse wave. So, meaning to say that these waves are traveling, the vibration of these waves are traveling perpendicular to the wave direction. So, as you can see here, the transverse wave of your electromagnetic waves are made up of two things. So, we have the electric waves or electric field rather, and also the magnetic field. Alright, so these two together are perpendicular, and aside from that, they also travel perpendicular to the wave motion, as what you can see here. This is what a typical transverse wave looks like. Alright, so electromagnetic waves travel in a constant speed of 3 times 10 to the 8 meters per second. Alright, so that's a constant speed, so it doesn't change. The only things that changes in your electromagnetic waves are the frequency and the wavelength. All right, so that is all about the simple properties of your electromagnetic waves that we have right here. Also, also these properties are interacting with each other. All right, so these properties affects one another. For example, the wavelength. If you have a shorter wavelength, therefore it contains high energy. All right, the wave contains high energy. So this is an inverse proportion between wavelength and the energy that the wavelength the energy the wave that you have carries. All right, Next one is the relationship between wavelength and the frequency. All right, the wavelength and then the frequency. So we agreed right here that it is inverse proportion. All right, so the wavelength is inverse proportion to the frequency of the wave. Okay, so the shorter the wavelength, the higher the frequency. And lastly, we have the relationship between frequency and the amount of energy. All right, so we agreed that the amount of energy is dependent to the frequency in direct proportion. Right, so they are direct proportion. So let's answer this question. Do microwaves have shorter wavelength than X-ray? So this question is false. All right, why? Because microwaves are located to the part of the spectrum that has longer wavelength. So X-rays are located to the part of the spectrum that has higher or shorter wavelengths. Okay, so that's the difference between microwaves and X-rays. Okay, more so, the electromagnetic waves are they can travel everywhere and anywhere. All right, so they can also travel in vacuum. All right, they don't need any medium at all. All right, so they don't need any medium at all to transfer energy from one point to another. So electromagnetic waves can be reflected, absorbed, or transmitted, depending on what kind of materials are we dealing with here. All right, so the type of or the waves behave differently on different materials. All right, and also the amount of energy that the wave carries also affects the behavior of that particular wave. All right, for example, okay, so the light waves are reflected by the skin. All right, the light waves are reflected by the skin. That is why we can see the skin color that we have. All right, it's because it is reflected. But there's one electromagnetic wave that can pass through skin, and that is the X-ray. All right. So the only material that they can't pass through is the bone. All right. So the one that you see here. So the skin is as if there's nothing. All right. The X-ray can pass through skin as if it is nothing, and it cannot pass through the denser material, denser portion of your bone. All right. So the peritoneum that we have right here. So this is the part of the bone which is the hardest and the denser part of the bone. All right. So okay, so when you have an X-ray, you will see your bone, all right, under that X-ray. So they can pass through the skin. Okay, so meaning to say that the X-ray can be transmitted through the skin. All right. So some electromagnetic waves are being absorbed. All right, some electromagnetic waves are being absorbed. Example here we have the X-ray, and also we have the infrared. All right, so we have the infrared. So our body is absorbing some infrared waves, and it increases our temperature over time. All right, when we go under the sunlight, right? When we go under the sunlight, our body is absorbing a lot of these infrared waves, and in effect, it hits our body. All right. So that's the reason why if we wear white clothes, all right, if we wear white clothes, our body feels much cooler because it reflects all forms of color. All right, all colors of light. All right. Whereas if we have a black colored clothes, all right, or darker colored clothes, the tendency is we will absorb, all right, our clothes absorbs all colors of light, therefore it increases our temperature. All right, so that is some materials absorb this particular colors of light. All right, it increases our temperatures, our body temperature in effect. All right, there are also some light, or there are also some materials that reflects light, especially shiny surfaces like the one that we have right here, which is the mirror, right? So this is the mirror, and also, okay, this material, all right, some of the energy may also be absorbed by these materials, but not all of them. Some of are being reflected, all right, to our eyes or to the environment. Okay, it goes back again to the environment, the light itself that is reflected. All right, example of this is the mirror, and we have here the satellite dish. All right, so the satellite dish that you have right here reflects the radio waves. All right, it reflects the radio waves to the receiver that you have right here. All right, to the receiver that you have right here, which is attached to your television. All right, so that's how your satellite dish works. All right, now you will be able to see your self in the mirror because light itself is being reflected through the mirror, because the surface of the mirror is, aside from being smooth, it is shiny. All right, something like that. All right, so these are the ways your electromagnetic waves can be okay, can be processed. It's either they can be absorbed, they can be reflected, or they can even be transmitted. All right. All right. So we go now to the electromagnetic spectrum part. All right. So we all know that the shorter the wavelength, the higher the frequency. Also, the shorter the wavelength, the more energy that the wave carries. So as you can see here, the wavelength varies in meters. So the longest one is the 10 meter on the radio wave, and the shortest one found in gamma rays. All right. More so, there is one thing that you should there's one thing that you should take note of: the harmful effects of these electromagnetic waves. Now, as you can see, as you go to the region of lower frequency, or higher frequency rather, as you go to the region of higher frequency, the harmful effects of the waves, or the electromagnetic waves, suddenly increases. All right, so they are directly proportional to energy. As the energy of the wave increases, also the hazard effects of those wave also increases. So it has more potential effects in our body in the long run. Okay, so that is the idea here. Also, we have some examples of this. We have some devices that are under your electromagnetic spectrum. Example, the radio waves. Right, so the radio waves that we have right here, the radio. All right, so the signal that is used by this radio is coming from a radio wave. All right, so next one, the signal that is used by our cell phones is the microwaves. All right, or are the microwaves. All right, and the one that I have right here, which is the one that is used by your remote control, okay, to control your monitors or television. Okay, the one that comes out here is an infrared rays, or infrared waves. All right. Okay, and more so, infrared cameras uses this kind of electromagnetic wave. Okay, next one is visible light. Okay, this is the light that we can that our eyes can see. Okay, so there's one thing we have here, the ultraviolet light. So the ultraviolet light is okay, can be produced, or can be encountered in sunlight. All right, and also it can be used as part of your mosquito killer device, the one that you have right here. This is a mosquito killer device. All right, also we have X-ray at 1 nanometer, and we have gamma rays on the far end. Okay, so these are some examples of devices that uses different ranges of electromagnetic spectrum. All right, so how many? You can pause this video if you want to. All right, so how many electromagnetic waves can you spot on this picture that we have right here? Right, so you can pause this video if you want to find out what are the electromagnetic waves that you can find in this video, or rather picture that we have right here. All right, so let's find them one by one. Okay, first one is the X-ray. Over here, the one that checks your luggage, so that is an X-ray. Next one, the television uses radio wave. Alright, so the camera that is used by this guy uses visible light. Alright, otherwise cameras will not work without visible light. Alright, next one, the red flashy thing that you have right here, the red flashy thing on your X-ray counter that you have right here uses red light. Alright, so which is part of the visible light. Also, the stick. Alright, so the stick that is used by the airport guide that you have right here, or airplane guide, is using visible light, which is yellow, red, or sometimes it is green. Alright, next one. The radar over here uses radio wave. Alright, the sun itself. gives visible light and gamma rays or small amount of gamma rays and also ultraviolet rays. All right, something like that. All right, so the grill that you have right here uses infrared. Right, so the grill that you have right here. Also, the bill counterfeit checker. All right. So the bill counterfeit checker is using an ultraviolet light to check some banknotes, right? To check some banknotes if it is fake or not. Next one, we have microwave, which is used by the microwave oven itself. All right. Next one, we have the mosquito killer on this side. And also the light that comes out of your refrigerator, that is a visible light, right? So that the light comes out of your refrigerator. All right. So basically, we can see on this picture a lot of devices, a lot of applications of your electromagnetic waves. Okay. So sometimes we take for granted them because we can see them. All right. There's a reason because the reason is we can see them. That is why some people take for granted those electromagnetic waves. But if we have an ability, all right, so guys, but if we have an ability to see these electromagnetic waves in general, all right, so if we have an ability to see these electromagnetic waves, so it will be a messy place. All right, it will. The world will be a messy place. Why? Because, example, if we happen to see, if our eyes is capable of seeing the electromagnetic or the radio waves, all right. Example, the radio waves. If we will be able to see the radio waves, the world is so messy. It's because you will see a lot of radio waves scattered around. All right. Especially if you are in a mall or in an establishment where people uses a lot of or where people uses cell phones, all right, laptops and other communicating device, you will see a lot of these radio waves scattered around, right? So the good thing is our eyes can only appreciate the visible light part of the spectrum. All right. So that is the applications of your electromagnetic waves. All right, so let's have here a short concept check. All right, if you understand the concepts a while ago. All right, so you can pause this video and rearrange this electromagnetic waves according to their wavelength. All right, so the first one will be the longest, and then the last one will be the shortest. All right, so let's start first with the first one. So what is the okay? Which electromagnetic waves that you have right here has the longest wavelength? All right, so number one will be the radio waves. Okay, next number two will be the X-rays. Rather, we have the microwaves. Okay, so the third one is the infrared waves. Okay, so the fourth one will be the visible light. And we have the fifth one is the ultraviolet light. All right, so the shortest, okay, the second shortest wave, which is the shortest wavelength, is the X-ray. And lastly, the shortest among them all is the gamma rays. All right, so that is your electromagnetic waves arranged accordingly to its wavelength. All right. Now, let's talk about the effect of these different electromagnetic waves under your electromagnetic spectrum on a living tissue. All right. So, but before we go there, let's take a look at this simulation. All right. So, I have right here a simulation from Crocodile Physics. All right. So, I have right here a simulation that shows the different wavelengths of light and the frequencies as well. Right. Okay, so the frequencies as well. So in this case, I have here a default, which is the light. So it is in green right now. Okay. So if I increase the wavelength, notice that the frequency also increases. All right. So also it affects the frequency. So as I increase the wavelength, the frequency decreases. So what happens to your light that we have right here? It becomes red because the red light has the highest wavelength. All right, it has the longest wavelength and it has the lowest frequency among the colors of light. More so, if we decrease the wavelength, as you can see, the frequency is decreasing, increasing as well. All right. So as an effect, but the wave speed still the same. All right. The wave speed is still the same. So as you can see, we are now on the green part. As we decrease the wavelength further, all right, to 380 nanometers, so the light becomes violet at 788 terahertz. That is the violet light that you have right here. All right, so let's take a look at the other forms of electromagnetic spectrum. All right, so we have right here, let's take a look at the microwave. Alright, so microwave looks like this. So it doesn't have any color at all. Alright, so since we can't see them, right? So it doesn't have any color at all. And if we increase the wavelength, so to its maximum, the maximum wavelength of your microwave is 1 millimeter. Alright, so 1 millimeter is the maximum wavelength under 0.3 terahertz. As you can see, all right, it's a bit sluggish. All right, it's a bit sluggish if we take a closer look about this one. All right, so if we increase, all right, if we decrease the wavelength or by 0.01 millimeter, we can see that the microwave can travel or travels much faster than the previous one at 30 terahertz. All right, frequency. All right, let's take a look at other wave forms. So we have right here the X-rays. So as you can see, the X-rays have a wavelength of 0.1 nanometer over here. Now, if we increase the wavelength that you have right here, right? So at 1 nanometer, the X-ray becomes sluggish, right? And the frequency is 0.03. All right, 0.3 rather. 0.3 times 10 to the 18 frequency. So if we decrease the wavelength, the X-ray travels at 30. All right, 30 times 10 to the hertz, 10 to the 18 hertz frequency. All right. All right, so we have here about radio waves. Okay, so the maximum frequency of your radio wave is if we increase the frequency, as you can see, the wavelength decreases. All right, so the maximum frequency that the radio wave can have is 300 megahertz. Okay, at 1 meter wavelength. All right, so at 1 meter wavelength. Now, on this simulation, you can see the relationship between frequency and wavelength. So as you can see also that the wave speed doesn't change at all because it is constant. All right, so that is the property of light and the different spectrum that you have right over here. All right, so let's go back to our main slide. Okay, so let's talk about the effect of these electromagnetic waves to the living tissue. All right. So as you can see earlier, that as the energy increases, the harmful effects of these electromagnetic waves also increases. So let's have another concept check. All right. So if you know that the energy is directly proportional to the frequency of the electromagnetic wave, so let's arrange this one. So you can pause the video. So to give you time to arrange this different electromagnetic waves in terms of highest energy. All right. So in terms of their energy, 1 being the highest and 7 being the lowest in terms of energy. All right. So let's start with the first one. So who is number 1 here? Obviously, we have here the gamma rays. All right. So followed by X-rays. All right. So the third one will be the ultraviolet rays. The fourth one will be the visible light. Okay, then the fifth one is your microwave, infrared rather. Okay, then followed by the microwave, the lowest among them all, the electromagnetic wave that has a lowest form of or lowest amount of energy is the radio wave. All right, so this is the correct arrangement for this particular concept that we have right here. So, did you get it right? Okay. So, just post it in the comment section of the video below. All right. So if you did get the right arrangement. All right. So let's start first with radio wave. Being the longest wavelength and the lowest energy, all right? So radio waves most of the radio waves passes through our body. Okay? Most of the radio wave passes through our body, so it is transmitted. All right? It is transmitted inside our body and it just passed through. All right? So radio, all right? Radio and some cell phones uses radio wave. Example of this is the Bluetooth. Alright, it's the Bluetooth device that are found on your cell phone that can be used as a form of data link, alright, between two devices. Alright, and also these radio waves are not absorbed by the body. Alright, these are not absorbed by the body. They always pass through our body but not absorbed. So in short, radio waves have no adverse effect on our body. Right? Radio waves have no effects on our body. It doesn't damage our DNA. It doesn't kill the cell after all. All right? So radio waves are very all right. So they are less hazardous, all right, in terms of amount of energy that they have. All right. The next one is microwaves. All right. The next one is microwave. Microwaves are being used as a way of communicating, all right, way of data transfer by some cell phones, all right, today. Okay, and these microwaves have shorter wavelengths compared to your radio waves, all right. Now, microwaves compared to radio waves, they are slightly absorbed by the body. Now, when we absorb this microwave, when we absorb this microwave, it can cause minor heating at the end. Alright, it can cause minor heating, which is probably it is negligible. Okay, it is not much hazardous. Alright, unless you use your device more often. Right, if you use your device more often, then it will cause a lot of heating. Alright, in the sense that you use your device more often. Okay, so however, okay, there are no studies shows that the microwaves have adverse effect on our body. So it doesn't cause cancer, all right, which these microwaves damages the DNA and cause cancer, something like that, or even they can kill or they do not kill any cells in your body in the process. So microwaves are useful, all right, in the long run in terms of communication. Now, just to show you how does the microwave, okay, how does a microwave from your microwave oven works? All right. Suppose that you put a food inside your microwave oven. All right. Now, even though you can see the microwave, all right, inside your microwave oven, still it can cook the food inside that microwave oven. How? Okay, these microwaves, all right, these microwaves are being absorbed by water molecules that are found on your food. All right, these are being absorbed by the water molecules that are found on your food, and then these water molecules suddenly vibrates rapidly. All right, as we all know, that temperature is the average kinetic energy of your molecule. So therefore, if your water molecules vibrates rapidly, it creates a lot of heat, all right, inside the food that you have in your microwave oven. All right, when it creates heat, it cooks the food inside using these water molecules that are rapidly vibrating using this using this microwave, all right, inside your microwave oven. Okay, so that's how you cook food inside your microwave oven. All right. So again, if you use your device more often, so it will cause some minor heating effect, but not this is negligible. All right. Now, more so, we have your infrared waves or infrared rays. All right. Now, infrared rays are absorbed by the skin. All right, but it doesn't go very far, farther than the muscle. All right. So, okay, they transfer the energy. So again, the idea is when something is absorbed, all right, there is a transfer of energy that is happening. Okay, when there is something that is absorbed. So when we absorb infrared rays by our skin, the tendency is the skin or our body will suddenly increase in temperature. All right, the tissues will start to warm up. Okay, And the good thing here is our skin has a thermoregulating device. All right, it has a temperature regulation sensor that tells us how much of this infrared rays can be absorbed by the body before it is critical. All right, so it tells us. So that is why our skin is very important in telling us whether the object is hot or not. All right, so there are nerve endings that are found on your skin. More so, infrared rays, all right, coming from the fire that you have right here, we can use that one. We can utilize that one in cooking our food. All right, in cooking our food. As you can see, exposure to infrared, too much exposure to infrared can burn your food. Same thing as your body. All right, same thing as your body. Too much exposure to infrared rays, it will burn your body. Okay, it will cause burn. So okay. So as much as possible, you limit your exposure to this infrared waves or infrared rays. So much your skin will not be burned after all. Okay, so that is your infrared waves. Also, we can use infrared rays in infrared cameras. All right. In infrared cameras, we can see colors like red being the hottest and blue, which is the coldest. All right. So that's the use of your infrared waves. All right. Next one is the visible light. All right. So what is special about visible light is this is the only part of the spectrum that our eyes can see. All right. That our eyes can see. So it took a million years before our eyes evolved into what eyes that we have right now. All right. So, okay, is visible light harmful? All right. So, is visible light harmful? So, they are not harmful after all. All right. Too much exposure to this visible light will make it harmful. Okay, too much exposure. For example, if you expose your eyes to too much bright light, it will cause blindness. All right, it will cause blindness, but it doesn't cause cancer. All right, it doesn't cause cancer or the other way around. All right, so it will just cause blindness. For example, looking at the sun through telescope or binoculars can cause blindness. All right, so just be careful on looking at the sun. All right, so make sure that you use a device that blocks this amount of sunlight. Okay, so that your eyes can tolerate this visible light that passes through it. All right. So next one is lasers. All right, lasers can affect your eye. All right, it can make you blind if you are exposed to that high powered lasers. Okay, because these high powered lasers can cut through metal. So okay, so if they can cut metal, they can also cut tissues. All right, they can also burn tissues. All right, so there is this blue light. All right, there is this blue light that are found on the screen of your emitted by the screen of your cell phones. So as much as possible, you just limit your exposure to blue light so that your eyes will not be damaged for after a longer period of exposure to this one. All right, so limit your exposure to this blue light. All right, so that is the visible light. Okay. All right, so we go now to. All right, we will just consolidate the three last electromagnetic waves that we have right here. This is the ultraviolet, the X-ray, and then the gamma ray. Now, these three are called ionizing radiation. Right? They are called ionizing radiation or ionizing waves, as what this slide tells us. All right, so now what is an ionizing radiation? This is an electromagnetic waves that contains high amount of energy. All right, they contain high amount of energy that can damage cells, or even they can change the composition or change the structure of any molecule that they encounter. All right, so in our body we have our DNA. Okay, so this ionizing radiation can damage our DNA if we expose ourselves in this electromagnetic waves for a longer period of time. All right, so which of this, some of this is the ultraviolet rays. Right? So ultraviolet rays, if you have a too much exposure to ultraviolet rays, it can cause skin cancer. Alright? So make sure that you limit your exposure to sunlight because sunlight contains ultraviolet rays as well. Alright? So wear sunblock. Alright? Wear sunblock lotion before you go under the sunlight. Alright? So to protect yourself from ultraviolet rays. Alright, example of this machine is tanning machine. Right? The tanning machine emits ultraviolet rays. All right, so it is used to make you darker. All right, so I don't know why people like to become dark, something like that. Okay, so that is the ultraviolet ray. All right, so next one is the X-ray. All right, so the doctor always tells us that do not expose yourself to X-ray. All right, more often. Okay, so you just have an X-ray twice a year, something like that. All right, so once a month or something like twice a year. Okay, something like that. All right, because X-ray can cause damage on our body, especially on the bones. All right, they can cause uh, leukemia or bone cancer. All right, if you expose too much on this electromagnetic wave. All right. All right, next one. We have gamma rays. All right, radioactive waste, okay, radioactive materials like uranium, all right, radium, something like that. Okay, it contains or they emit gamma rays, all right? They emit gamma rays as they decay. All right? As they decay, they emit gamma rays, and once you expose yourself to gamma rays in a short period of time, all right? In a short period of time, it can cause a lot of damage to the DNA. Okay? Also, it can even kill cells. All right? It can even kills tissues and cells inside your body. All right? So, example, the one from the Chernobyl disaster, the one from the Chernobyl disaster. All right, there's a person there which is it receives or that person receives too much exposure to gamma rays in which his skin, all right, his skin starts to peel off from the bone. All right. So that's the effect. All right. Too much. That's the effect of too much gamma ray exposure. So make sure. All right. So make sure if you are working on a highly radioactive environment, so make sure that you wear radioactive suits to protect you, and the environment must be properly shielded. Okay, talking about properly shielded, what is the material? All right, what is the material that we can use in order to shield ourselves in these forms of radiation? All right, so is there a material that we can protect ourselves? All right, in this form of radiation. All right, yes, there is. So I can show you that one in our simulation. Okay, so in this simulation, we will try to find out what is that material that we are talking about. So as you can see here in our control variable or controlled environment, so as you can see here, the X-rays is being transmitted, okay, around a space. All right. Now, it is received, all right? It is being absorbed by this person that you have right here. Now, the amount of radiation that this man is being absorbed is around 59.27, all right? So, 59.27. So, that is for the X-ray. So, let's take a look at the gamma ray. All right? So, gamma ray radiation, all right? So, it's the same thing, but it has a higher in terms of decimal place. Alright? So 59.43. Alright. Now, which of this particular material can block this ionizing radiation that we have right here? So obviously, alright, let's start first with the X-ray. Right. So obviously the bone, right? So the bone is alright, so how much can we receive? Alright, so we have 39. So we still have 39, but this is still higher. So the bone cannot properly or cannot shield us, alright? So if you have a bone wall or something like that, the bone cannot shield us from X-ray. And if X-ray can pass, more so, the gamma ray can also pass through the bone. Alright, so next one is the air. So logically, air is okay, so we will not put air anymore here. So logically speaking, the air can allow X-ray to pass through. All right, so let's delete this one. Let's take a look at brick. Okay, suppose you have a concrete barrier on your house. Is it possible to block the ionizing radiation using only the concrete barrier? All right, so as you can see here, it doesn't block a lot of radiation that we have right here. It doesn't block a lot of radiation. Right? So the brick fails to shield us yan, from radiation. Alright, next one is the muscle. Alright, so I don't know if the muscle can protect us. Okay, if you have a muscle wall, alright, suppose you have a muscle wall, right? So the thing here, it cannot protect us, okay, from X-ray. So as you can see, I do not change it to gamma rays because logically speaking, if X-ray can pass through, more so the gamma rays. Alright, so next one. We have aluminum. Alright, so we have aluminum. So let's see if we can shield ourselves using aluminum. So, okay, we can shield ourselves using aluminum, but it is still high. Alright? The exposure on this human body is still very high. Alright? So, aluminum fails us to shield. Right? To ionizing radiation. Alright, let's go to the last one. So, vacuum. Alright, so I will not put vacuum here. Logically speaking, electromagnetic waves can travel through vacuum. Alright, they can travel through vacuum. So, why putting vacuum here? Alright, so we put now the last one, which is lead. Let's see if lead can protect us from ionizing radiation. Alright, so as you can see here, it protects us from ionizing radiation. Alright, lead is a good material in shielding us from ionizing radiation. It must be this thick, I think. It must be this thick in order to protect you from radiation. So as you can see from 59, all right, earlier we have now 0.25. All right. Now if X-ray cannot penetrate, let's try gamma rays. All right. Also with the gamma ray, it cannot penetrate. Okay, it cannot penetrate through the lead wall that we have right here. So that is why most of the nuclear power plants are built inside with lead shielding. Alright? Aside from concrete, it has a very thick lead shielding so that the workers inside the nuclear power plant is properly protected and shielded from ionizing radiation like gamma rays, X-ray, and ultraviolet rays. Alright? So, now, what if you may ask, what are the properties of lead which is good for shielding us in ionizing radiation? Number one is its density. Lead has the highest density, okay, in all your elements. One of the highest density in all your elements. So, it protects us from ionizing radiation by exploiting its density. Why it has a lot of density? It's because it has a lot of electrons. Alright? It has a lot of electrons that can block this ionizing radiation that you have right here because of those electrons. Alright? So it has numerous electrons. Alright? So lead is a good shielding for ionizing radiation. Alright? So let's go back now. Alright, so with that, we know that we can now protect ourselves using lead, right? In this ionizing radiation that we have. Alright, so food for thought about this one. Limit your exposure. If you encountered one, limit your exposure as much as possible with this ionizing radiation. Alright, next one. Alright, so to sum up everything that you have encountered in this video lesson. Okay, to sum up everything. Alright, so let's try to find out. Okay, you can pause this video if you want to have time to answer this short puzzle that we have right here. Okay, so what are the different effects? Alright, what is the different effects of these waves to our tissues? Alright, so what are the effects of these waves to our tissues? Okay, first is the radio wave. Obviously, the radio wave has no effect because it has low energy. Alright. Next one. Microwaves. Microwaves has a slight higher energy compared to radio waves. So it has a it will just heats up our body, but not in a higher amount. All right. Next one, we have an infrared. All right, infrared waves will increase our body temperature. Okay. Excuse me. All right. So next one is the visible light. All right. So the visible light is okay. Right, so the visible light is somewhat harmless, but in longer exposure, it can cause blindness. So, okay, so let's see, where is it? Okay, so it is right here. All right, and finally, we have the ionizing radiation. So, obviously, the ionizing radiation, because it has a lot of energy, it packs a lot of energy, so it can kill or damage DNA cells. All right, so did you get it all right? All right, so just put your reactions in the comment section. So if you got it all right. Okay. All right, so with that, okay, that ends up our video lesson for this session that we have. So that is the forms of electromagnetic waves. So I hope you did learn something from that video lesson. Okay, and if you did learn something from that video lesson, just hit the like button on this video. Subscribe to my channel and ring the notification bell to update you to more videos. All right. So the next video lesson that I will have is the dual nature of light. So if you want to be updated on that one, so hit the notification bell for this video. Now, if you have question and suggestion about this video, you can put it down in the comment section below. All right. So that's it, guys. Let's see each other to the next video lesson. All right. So have a nice day, guys. Peace out.
子供なのね夢を追って傷ついて嘘が下手